Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni. Today we are going to discuss another topic from the chapter solid state, and that is nothing but the unit cells. Okay, so it belongs to I have already uploaded some images on the board. I'll explain what are these images one by one. We are discussing unit cells. Okay. Yes, so first of all I will explain the meaning of this word unit cell with the help of a simple analogy, simple example. If you have seen the big apartment, the big story buildings, which are you can see in the metro cities, so they are having different or so many flats or so many houses in it, right? So you are going to assume one such a building in which all the rooms are of the same dimension, of the same type, same size, everything is same for all the rooms present in that particular building. Okay, yes, so all the rooms are having the same dimension, same size, same shape, everything is same, right? Okay, so whenever that building is getting constructed, being constructed, first of all the base of that building is built, on that the first room is built, and on above the first room the next other remaining rooms are built, or surrounding to the first room remaining other buildings are built, right? That means that first room, which is you can see just the size of or the shape of the room in which you are sitting, that is also just like a cubical shape, right? Cube. So if I assume that one room in that one building is nothing but a cube, right? So that cube will be representative of all other units, right? That cube will be representative of all other rooms available in that whole building, right? Okay, therefore that room or that cube is called as the unit cell. Okay, just like cell is the smallest fundamental and what you can say, smallest fundamental entity in the human body, right? Living cell, or the neurons are the smallest fundamental particles of brain, or the photons are the smallest fundamental particles of sunlight. Likewise, the unit cell is the smallest or atom is the smallest fundamental particle of all matter in the nature. Similarly, unit cell is the smallest fundamental repeating unit of the whole crystal lattice, or the whole crystalline solid. We are talking about solid substances. Solid substances are crystalline in nature. Crystalline means what? We have already discussed about the crystalline and amorphous solids. Crystalline substances, the best example you can assume in front of your eyes is diamond. Diamond is crystalline in nature. Sodium chloride is also crystalline in nature. Sugar is also crystalline in nature, right? So what you see about all these examples, that these they are having crystal structure, or they are having a specific geometry, right? So for such a crystalline substances I am talking about, the smallest fundamental repeating unit is known as the unit cell, right? Okay, now just like different architects are having different ideas in their mind, different engineers are having different ideas in their mind to create different type of houses, different type of buildings, right? So some of them will prepare the room just like a simple cube, just like a simple cube. Some of them will incorporate some new ideas in it, right? So based on this incorporation of new things, or not at all a simple room, based on that the whole crystal structure will be different, right? Now I am going to show you three such different types of unit cells. Okay, I am going to show you three such different types of unit cells one by one. The images I have already uploaded. I am just going to explain them first of all below, then I will again go back to the images, right? What we are going to see, we are going to talk about the unit cell. Unit cells are nothing but the smallest fundamental repeating unit of the crystal lattice, right? Okay, so there are two main types of the unit cell. Okay, the first type is called as the simple cubic unit cell. Simple, which is also called as primitive, simple or primitive cubic. Why cubic? Because its shape is just like a cube. just like the room is cubic in which you are sitting, it is having a shape of a cube. Okay, cubic unit cell, this is the first type of unit cell, simple or primitive cubic unit cell. Whereas the another type is called as the centered cubic unit cell. Centered cubic unit cell. What is the meaning of these two things? I'll explain now. In case of simple cubic unit cell, the atoms, atoms are constituent particle. For some crystals it may be atom, some crystals it may be metal, some crystals it may be ion. It depends on the nature of the substance, right? Okay, just like for sugar crystal it will be atom or molecules. For sodium chloride, the salt, it is ions, right? So it depends on the nature of that substance. Okay, therefore instead of writing atom, ion or molecules, I'll write down constituent particle. Okay. So yes, in simple or primitive cubic unit cell, the constituent particles okay, constituent particles are also, we are going to call it as spheres, right, or atoms. Okay, these are the all the words used to express this. Atoms are present at only corners of a simple cube. There are 8 corners to a cube. Okay, you can count the corner present in the room in which you are sitting. There are 8 corners, 4 above, 4 at the floor, right? Okay, so in case of simple or primitive cubic unit cell, the atoms are present only at the corners, right? Yes. Now in case of centered cubic unit cell, the atoms are present at, okay, the spheres only I'll write down. I will not write down atoms and constituent particles again and again. The spheres are present at all corners, as well as some other locations. Okay, apart from corners are there always. Corners are there, but apart from corner, some other positions are also having atoms, right? Okay, as well as some other positions. Okay, yes. So these are the centered cubic unit cell. Now there are again 2 types of centered cubic unit cell. Okay, on the base of okay, there are again 2 types of centered cubic unit cell on the basis of what is the position of that particular extra atom, not the corner, the extra atom, other position wala atom. So it may be of 2 types. One is called as body centered cubic unit cell. Body centered cubic unit cell, which is abbreviated as BCC, body centered cubic unit cell. Another type is called as face centered cubic unit cell. Okay, face centered cubic unit cell is abbreviated as FCC, body centered or face centered cubic unit cell. Okay, now what are these body centered and face centered cubic unit cell? I will explain with the help of diagrams. Okay, now let us see first of all the diagram for the simple or primitive cubic unit cell. I hope you can see the diagram here. So these structures or diagrams of these crystals or unit cells of crystals can be shown with the help of 3 types of diagram, 3 types of structure. First one is called as open structure, space filling structure, and actual portion of the atoms, right? What is the meaning of it? I'll tell you. First of all, let us talk about the open structure. Okay, open structure means what? First of all, they have simply drawn a cube, right? And at the corners of the cube, as this is the simple cell, at the corners of the cube they have drawn the spheres. That's it, right? In space filling, what is the difference? They have not drawn the cube, they have only shown the positions of atoms at the corners. But here they have shown the actual shape or actual what you can say size of the atom. As we know, atoms are spherical in nature. Therefore, in this case what happens, this is the actual or correct what you can say correct way to express the this unit cell, right? Okay, in case of open structure, what happens, guys? The this Yes, in case of open structure, the atoms are looking just like they are away from each other, but that is not the case. Atoms are not away from each other. Ideally, atoms are touching each other, like these two atoms are touching. This is touching here, this is touching here, this one is touching here, this one is touching here. So it will give rise to the space filling model. Open structure model is used to explain some other simple thing related to the cube, but ideally this is the original structure. Ideally all the atoms are connected to each other, they are just attached to each other. Okay, all the spheres are just attached to each other, just like if you just take all the 8 balls, okay, 8 spherical balls, as ball is spherical in nature. If you stick all the balls together, 8 balls together in such a way that they are making a cube, so this kind of structure will give rise to the space filling structure. Okay, yes. Now what is the actual portion of atoms, that also I will explain. Okay, for that purpose let me just show you something. Okay, right? Okay, just assume that you are talking about your room, you are talking about your room. Okay, so this is your room. Okay, okay, I am drawing a square, but assume that it is just like a cube, it is cubical in nature. This is your room. Okay, now on your floor, okay, on your floor there is one more neighbor who is living. Okay, on your full floor there is one more neighbor who is living. Okay, so this is your neighbor, right? Okay, now this is the first floor, you can say, for an example. Okay, this is the first floor, you can say for an example. Now similarly on the top floor, okay, or on the upper floor, that is second floor, also the another neighbor is living. As I have told you, all the rooms are cubical in nature. Okay, another neighbor is living here on the second floor. This is the second floor, right? And then here there is one more neighbor to that also, so like this. Okay, so this is the second floor, right? Okay, so this is the second floor, this is a first floor, and I am drawing ground floor also. Okay, there are people living in the ground floor also. Okay, the ground floor also people are staying. Okay, yes, so this is nothing but the ground floor. Okay, now this is your room, right? Okay, now as I have told you, there are 8 corners to every atom, right? Every cube has 8 corners, right? Okay, but forget about 8 corners. Here I am just showing a square just for the understanding purpose. Okay, but just I hope you can understand, all the rooms are cubical in nature, they are just cubes. Okay, now if I assume that this is the atom at the corner. Okay, there is atom at this corner, this is the corner of my room, right? I am sitting here. Okay, I am sitting here, and this is one corner of my room which I am observing, right? Okay, if there is an atom here at this position, right? If there is an atom at this position, now this atom is not only meant for me, right? Even if I am observing it from my side, it is not at all only meant for me, right? Okay, now this atom, some portion of this atom is for me, some portion of this atom is for my neighbor from first floor, some portion is for the neighbor who is on, as I am talking about atom here, the upper layer will be the second floor. If the atom was here, then lower layer I would have considered ground floor, right? So here the atom which I have shown by the black sphere, that is not only meant for me, that is with me, all my three neighbors, right? On that floor there will be three neighbors surrounding to me, right? Okay, so that will be shared in between, at first floor in between 4 atoms, at second floor in between 4 atoms, right? So this is how the single atom is shared in between how many total rooms. Single atom at the corner is shared in between how many total rooms? It is shared in between total 8 rooms. Room is nothing but the cube, right? Okay, therefore even if you see this atom just like here, right here I am showing it like this atom is only for this cube only. No, even if it is shown it like this, but ideally only 1/8 part is for this room, this cube. Remaining part is for remaining 7 rooms or remaining 7 cubes, right? So what is the portion which is for the contribution of this particular unit cell? Just 1/8, because single atom at the corner is shared in between how many total rooms, how many total cubes? 8 rooms, right? Okay, now this actual portion means what is the actual contribution of that particular? Can you see? This is 1/8, 1/8, 1/8 at each corner, right? Okay, so this is how, this is the simple or primitive cubic unit cell. Okay, now after simple or primitive, the next is body centered cubic unit cell, BCC. Now what is body centered? I have told you, in this case there will be all corner atoms, always there will be corner atoms will be present at 8 corners. Apart from corner, there are atoms at some other position. What is that other position? It is body center. Okay, it is body center means what? Center of the body. Okay, just imagine the imaginary center, something is hanging at the central portion of your room. Okay, that is called as a body center. So if there is an atom at the body center, this is the body center position, right? Okay, that will be, that type of unit cell will be called as body centered cubic unit cell, right? In this case, that central part of body or central part of room is only for your room, right? That will not at all be shared with others. Do you understand? Because that is only meant for you. Okay, because it is completely isolated from other rooms. Okay, so this is the space filling structure of the body center. This is the actual portion, right? You can see this is the body centered atom. It is, whole atom is shown for this cube because it is not at all shared with the others. Okay, then next is the FCC, that is face centered cubic unit cell. In case of face centered, what is the case? There will be atoms at all the 8 corners, that is always there. Apart from 8 corners, there are atoms at centers of faces. These are the centers of faces which I am highlighting by black. These are the face centered atoms. Okay, what is the meaning of face centered? I'll explain. So can you see, if you count while studying this structure, unit cells in solid state, just always assume your room in which you are sitting. To that room, how many walls are present? Total 6 walls are present. Okay, I am counting the top and bottom also, right? 1, 2, 3, 4, 5 and 6, right? How many walls are present for one room? Total 6 walls are present. Wall is nothing but the face. Okay, wall is nothing but what? Wall is nothing but the face. So if there is an atom exactly at center of each wall, okay, exactly at center of each wall, then that will be called as face centered cubic unit cell. Atoms at corners are always there. Apart from corner, atoms are also present at face centered. Face center means center of the wall. How many walls are present in any cube, any room? 1, 2, 3, 4, 5 and 6, right? So at the center of all these walls, all these 6 walls, if atom is present, that is called as the face centered cubic unit cell. Okay, now here let us see the contribution wala part. Okay, so something is there, you can see, you can just assume your neighbor and you, right? Here the one diagram is shown. So A is you and B is your neighbor. Okay, and this is one of the wall which is common in between you and your neighbor A and B. If any atom is at the center portion of this wall, right? So half of this atom will be for you, half of this atom will be for your neighbor. Do you understand? Because it is on the wall. It is, and wall is common in between you and your neighbor. Right? So what is the contribution for each room? What is the contribution for each cube? 1 by 2. Do you understand? So if atom is present at the face centered position, contribution is 1 by 2. If atom is present at body centered, no contribution. Directly it is meant for that atom. If atom is present at the corners, contribution is 1 by 2. Okay, do you understand this? Just take a screenshot of this page first of all, and then I will explain few more things related to this unit cells. Okay, now take a screenshot of this part also. Okay, now we are going to see the contribution part, and how the number of atoms per unit cell are calculated. Okay, that part we are going to see. Okay, so the next concept is number of atoms per unit cell. Number of atoms per unit cell means what? Okay, like atoms are at the corners, they are present at the face center, at the body center, but what is the exact portion of that atom it's meant for that particular cube? Because you can see, even if it's atom at 8 corners, but all these 8 atoms are not meant for one cube. For one atom, 1 by 8 portion is meant for one cube. Face center also, only 1 by 2 portion is for you, other is for your neighbor. So therefore, what is the exact number of atom that is meant for that single cube, that single unit cell we are going to calculate? So this is called as number of atoms per unit cell. Okay, this is called as number of atoms per unit cell. First of all, let us talk about the simple cubic unit cell. Simple cubic unit cell is also called as primitive cubic unit cell. Okay, in case of primitive cubic unit cell, atoms are present at the corners only. Okay, atoms at corners only. Okay, how many corners are there for a cube? 8 corners are there, right? So to find out this contribution, one simple formula I am going to tell you. To find out this number of atoms per unit cell, one simple formula. So number of atoms per unit cell. This formula is applicable to all types of unit cell, not only for simple. So here you have to do this part, contribution part I have explained to you already. Multiply this contribution by total number of atoms at that position. Okay, total number of atoms at that position. At that position means whether it is at corner or at body center or at face center, right? Okay, therefore the number of atoms per unit cell for simple we will calculate. There are 8 atoms present, they are present at corner. For corner the contribution is 1 by 8, right? 1 by 8 multiplied by 8 will be equal to 1 atom, right? Do you understand? So what is the total number of atoms per unit cell for simple? Just 1 atom. Okay, then second we will discuss for body centered body centered cubic unit cell, BCC, body centered cubic unit cell, BCC. So for BCC, atoms are present at corners. Okay, atoms are present at corners, as well as atoms are also present at body center, right? Atoms are also present at body center. How many atoms are present at corners? 8 atoms. Okay, how many are present at body center? 1 atom. So let us find out the number of atoms per unit cell. So number of atoms per unit cell, number of atoms per unit cell will be equal to, same formula you will use, and that is contribution multiplied by total number of atoms, total number of atoms at that position. Same formula, total number of atoms at that position. Okay, yes, let us see. Now here we will calculate it for 2 times, right? Like, because there is there are atoms at corners as well as at body center. First of all, I'll write down for corner. 1 by 8 is the contribution for corner. Total number of atoms is 8. So this I'll put in bracket. So, and I'll write down this is for atoms at corner. Okay, atoms at corner. Okay, plus I'll write down now for the atoms at body center. For body center, 1 is the contribution, right? I have told you, because body center atom is not at all shared with any other room. 1 is the contribution, 1 is the total number. So I'll put it in bracket and I'll write down this is for body center, at body center. Okay, yes, therefore I can calculate it. So it will be equal to 1 by 8 into 8 is 1, 1 into 1 is 1. So total number of atoms per unit cell for BCC is 2 atoms. Okay, very easy. Then third I will show you now. Third is for FCC. FCC, that is face centered cubic unit cell, FCC. Okay, face centered cubic unit cell, in which atoms are present at corners. 8 atoms are present at corners. Apart from at corners, atoms are also present at face centers. Okay, how many faces are there? 6 faces are there, right? Therefore there will be 6 atoms at the face centers, right? Same formula I am going to use again. So number of atoms per unit cell. I will not write down the formula again. It will be equal to, first of all I will write down for the corner. So for corner, contribution is 1 by 8, number of atoms is 8, right? I'll put it in bracket. So this is for atoms at corner, 8 corners are there. Okay, plus now I will write down for atoms at face center. For face center, contribution is 1 by 2, you and your neighbor. Total number of atoms is 6. 1 into 1 by 6 is for at face centers, right? Okay, at face centers. Okay, now let me do the calculation. 1 by 8 into 8 is 1. 1 by 2 into 6 is 3. So it is equal to 4. So what is the number of atoms per unit cell for FCC? 4 atoms, right? So this is how we have calculated the number of atoms per unit cell. Okay, for, let me just write down. So total number of atoms per unit cell for simple, then BCC and FCC. It was 1, 2 ka 4. Okay, 1, 2 ka 4. So this is how you can remember that these are the total number of atoms per unit cell for different types of the unit cell. Okay, yes, take a screenshot of these pages. Okay, I hope you understood this. If you have any question in this calculation part, please let me know in the chat box. Okay, and then take a screenshot of this remaining portion also. Okay, remember this, like simple BCC, FCC, 1, 2 ka 4. How I have calculated 1, 2 and 4. I hope it is clear to you. If it is not clear, then please let me know, I will explain. Done? Okay, so thus we have learned in today's class about the unit cells, right? There are there can be more types of unit cells also, right? Some what you can say, exceptional examples of unit cells can also be there. Like sometimes some atom from some position can be missed, sometimes some extra atom can be present at some other position also, right? So these things you will learn slowly when you will learn their three-dimensional structure. What is the next step after unit cell? The next step is how actual crystal is built in 3 dimensions. Okay, so when you will learn that, at that time you will understand the another types also. But this is a base. If you understand this, you will be able to understand all the other things in this chapter very well. Okay, so there are these 3 main types of the unit cells: simple, that is primitive cubic unit cell, body centered cubic unit cell, and okay, yes, just a minute, Abhishek, I'll show you the image first of all. Okay, so this is the BCC, body centered cubic unit cell. I hope image is visible to you. Okay, so in this case there are 3 diagrams: open structure, space filling, and the actual portion of the atoms. What is the meaning of it? I'll tell you first of all. I'll tell you the analogy, simple analogy to understand BCC. Always remember that the unit cell is just like a cube. It is cubical, and it is just like the room in which you are sitting. Okay, your room is also cubical in nature, right? If you observe your rooms, there are 8 corners: 1, 2, 3, 4 top and 4 in the bottom, right? So there are 8 corners to a room, right? If you assume that there are 8 spheres, 8 balls, 8 footballs, you put at all 8 corners of your room. Okay, all 8 atoms at all 8 corners, right? That means you have occupied all the corner position by the atoms. Apart from all these 8 corners, if you just hang, you can just imagine that is one ball is just hanging exactly at the central position of your room. Okay, exactly at the central position of your room, then that type of unit cell is called as body centered cubic unit cell. Why this is so? Because that's exact center part of your room is called as the body center. Okay, if apart from all corners always should be occupied. Apart from all corners, if atom is also present at body center, that type of unit cell is called as BCC, body centered cubic unit cell. Okay, yes, now let us talk about the contribution wala part. I hope space filling and actual portion you understand. Just assume that you are staying on first floor, right? You are staying on first floor. Now you are the one person, or your room is the one room. Apart from your room, there are 3 other rooms, right? Okay, there are 3 others. So total room on first floor is 4, right? Total rooms on first floor is 4, and apart from that, the second floor also you can consider, in which also there are 4 rooms. So total 8 rooms are connected to each other, right? They are joined to, they are linked to each other, touching each other. If I am talking about any atom at any corner, right? That atom, even if it is looking for me only, but its some portion, just some portion is for me, its remaining portion is it is shared in between all the 7 rooms. Okay, out of 7, 3 are present on first floor, remaining 4 are present on the second floor, right? So that atom, that single atom which was at corner, it is not only for your room, it is not only for me, it is shared in between total 8 other rooms. Okay, first floor and second floor, first layer, second layer, right? That means if I am talking about actual portion which is for me of that atom at corner is 1/8. Do you understand the contribution at corner? Now let us talk about the atom which is present at body center. Now that body centered atom is only for me, right? No one is going to touch, or no one is going to share that atom at the body center with it, right? Because that is only for me. Okay, just like this, any object inside your room, it's not touching walls, it's not touching corner, it's just inside your room, that is only yours, right? Okay, that is not at all, you are not at all going to share it with your neighbors. Okay, so exactly center position, that is body centered atom, is not at all shared with any other, therefore its contribution is just one, right? So this is the body centered cubic unit cell. Now let us see about its number of atoms calculation, right? Now for that purpose I have told you, you have to use the same formula. This formula is applicable for all types of unit cell, not only for simple. All this formula, remember, contribution multiplied by total number of atoms at that position. For BCC, atoms are present at corners as well as body centered, right? So we have to calculate the number of atoms separately. First of all at corner, then at body center. For corner, contribution is 1 by 8 and there are 8 corners in a room. So 1 by 8 multiplied by 8 for corner. For body center, there is only just one body center, right? For one room, one body center. Contribution is also 1, number of atom is also 1. So 1 into 1 for body center. So if I solve, it comes out to be 2 atoms per unit cell for BCC. Okay, do you understand why it is 2 atoms per unit cell? Now if you understand this, Abhishek, you will be able to solve the questions, numericals, based on this concept. Okay, now in if you observe the competitive exam question papers, JE or NEET or any other, you will see they will not directly ask the question, okay, like what is the number of atoms per unit cell for BCC. No, you will never see such a type of question. They will do some kind of modification, like they will, just like I have told you, they will remove some atom from some position, some corner they will keep empty, they will add extra atom at some another position, and then they will ask the question. So at that time you have to modify your solution. Do you understand? Yes, Abhishek, do you understand it now? BCC. Okay, thank you so much, thank you so much. If you have any question apart from that, please let me know. And yeah, so do you know, Abhishek, that on your portal you will be able to see DPP, daily practice problems. Okay, so that also I'll show just in a few seconds. It will take only few seconds. Just give me a second, I'm just showing something to you. So I hope you can see, this is a teacher's portal actually. Similar is yours. You have to go to resources, then on the left hand side all the way down you have to go to writing material, and then you can click on DPP, that is daily practice problem. You can download it, you can write down the solutions on your notebook or on a blank paper, anything, it's up to you. Just you have to take a picture of that and just upload it on the portal, okay, so that I will evaluate and let you know the suggestions wherever required. Okay, yes, so that's all from my side for today. Thank you so much, Abhishek, for joining. Thank you so much for your time, and all the best to you. Take care.